All right. What we're going to do today is ta-da, the quiz. Ta-da. And then the folks that are going to miss the quiz, they get to have a different quiz because we're going to go over the quiz today. Also, we are going to be playing with serial kits. And we're going to be connecting computers to computers using the 9-pin serial port that looks like that on the back of your towers. Why? Well, this is how you configure all network switches in a computer room. You do not need a GUI to manage your enterprise. Before we got all fancy with shared keyboards and mice and all this other fun things, everything was run over serial ports. So all networking and everything, it was all serial ports, and you had 64 pit multiplexers that would take all the serial ports and put them into a single cable, and then you run a lease line through the phone company to your other location, run it to a multiplexer, split it out to go to individual terminals back in the dark ages. And so today we will be playing with that. And what I'll do is I'll start with a little bit of that, of what we'll be doing. I have in front of me here a Raspberry Pi. Now, this Raspberry Pi is a version 3, and let me find the right terminal window. That it's the one without color. Yeah, here we go. All right. I am going to say, quick, remember that ancient quiz? Write a for loop? Oh, yes, you're going to get that again. Okay, so ready? We're going to do it on the command line, and we're going to make it very simple. So we'll call it count is equal to sequence 1, and I'm going to go to 100. And then I say for x in $ count do. And then I'll just say echo $x done. And just let it do its thing. Okay. Except that's too fast. I want it to slow down. So what I'm going to do after echo x, I will put in another semicolon and say sleep 1. So now it's going to sleep for a second for each one of these. Now I'm connected to the Raspberry Pi. I want you to notice something. I've just disconnected the network. I've disconnected the keyboard. Disconnecting. It's kind of still working because the serial port has 5 volts, or excuse me, now it's going to stop working. This is a special cable that I ordered from Adafruit that has a little converter in it for USB signals for transmit receive and 5 volts. So under the right conditions, you can run your Raspberry Pi on just a serial port. Now, why would you want to do this? Your clock or some other thing like Zach's hot tub, something you really don't care, it's like it doesn't need network connectivity. Okay. So we are going to experiment with this today. And the Raspberry Pi does not have a 9-pin connector. So that cable that you buy from Adafruit is in essence this connector, which is on the back of each one of these computers. So you're going to connect to a different computer And I'm going to show you how to do all that today, now that we're all here after our quiz. Okay, so let's do this. Go to 231 here and using Ansible, turning off all the computers. Turn off all your phones. Put away. Share screen. Don't think it's going to have enough juice. Not quite. Quite enough juice to power everything. Yeah. Now you can read it. Okay. All right, everybody done? You're all done? Pass it on in. And then I'll go over the answer. Get your names on it. Sorry. No worries. Report.
Funks dot x.
Thank you.
And then to source it, I can't do source
All right.
dot x. Okay. Use the JK.
All right.
Oh,
Now let's turn the computers all back on. I'll use the Ansible stuff.
just vi dot x.
Now, all this is doing is using port 9, and it's sending a teeny tiny packet to your network card by way of your MAC address, and it turns your machines on. Okay. All right. Now, let's have some fun with serial ports. It's a little hard to see, but on the back of your machine, I'll use this one back here. I'll raise it all the way up so we can kind of see. This one goes up, and so does that.
This is how I ended up with the standing desk. But look at the iron. Now watch it get stuck. It won't go down. All right. Your 9-pin connector is right here. You can barely see it from up there, but everybody has one of these on the back. What we're going to do is, let's say you want to run your computer. So this is the side that plugs into your computer. This means what you. And this is going to the back of your phone. Providing it's long enough. Okay. So what happens is, now that I plug this thing in, there's some things I need to do. Configuration. Now, what I'll do is I'll show you the configuration. And I don't think this machine up here has a serial port. So I will have to cheat. Yeah. Excuse me while I disappear. I am correct. There is no serial port. So what I have to do is I cheat. There's this little adapter that is a USB on one side and a 9-pin on the other side, except it's a little hard to see. I think I got 2 of these. Oh, I only got 1. I'm just going to pass it around to show you. But if you look on the back of the computer, you can see that the pins stick out. That's the male connector. When I ordered these, I goofed. I put the female connector on it. So I need a gender mender to make it work right, okay? So what happens is I plug this in and then I will now have a serial port on this machine, okay? But for the sake of argument, let's use this little guy. So this is going to be the one that will be similar to, and I use this guy for lots of different things. Having a bigger keyboard makes life much easier. So let me get it to work here. Loading password. I heard it pop, so that's one good thing. Okay, there's good. Let's open the terminal. I need to use the X-Rander thing. Get that fixed. All right. How do we enable serial ports on our machines? Now, this is something that is probably not in test out. Go ahead and grab a last blank, yeah, and go ahead and do your quiz. No cheating. All right, you guys on either side of it, make sure he doesn't cheat. If he cheats, he has to run around the building 14 times, okay? So setting up the serial port, there's 2 ways. We want to connect to something, and then we want to be able to receive something back. Now, part of the reason I'm doing this is for you guys' projects, you're doing in 290, okay? This is directly related to what they need to get done. And this is the kind of thing, I don't know if, well, in the 290 class, maybe you haven't heard it yet, but Scott Fernandez, who used to be in networking, would hand this to a new hire and say, here's your notebook, here's the switch, make it work. It's connecting a serial port. It's like networking 101 for people who want to be a network engineer. And nobody teaches you how to do that. So it's like, how do you do this, but nobody teaches you? Well, it's classic. You don't know what you don't know until somebody points it out that you don't know it. You're going, oh, I didn't know I need to know that. Serial ports are something you need to know. Okay. And I'm pointing it out. Okay. So on the modern versions of our Debian, Ubuntu, they make things so easy. All you need to do is say system control, and then I can never remember it. I'm going to say status so I can remember. I think it's getting. And again, this is VI binding. I'm using the J key. And I believe it's Getty serial or serial Getty. I can never remember the order. May not even be on this one. Isn't it nice to know all that stuff runs? Thermal V, 13, there we go, get closer. See? That's a good name, isn't it? Switcheroo. The Switcheroo Control Service. Who knows what that means? Okay. Pardon?
For integrate that, right?
Oh, probably. I haven't looked into it. TQID. There it is. All right. Getty serial close. So it doesn't look like I have it. Good. All right. Let me look at my notes. That should be root, that should be system control, and then say start. Serial. It's Getty serial. This. All right, let me go look it up. The advantage of knowing where stuff is, but what computer is it on, right? This is something that has evolved a great deal over time. There it is. System control, enable serial dash Getty. Start serial dash Getty. And then which 9-port connector? If you take the A+ exam, they're going to ask you the COM port 1 and COM port 2. What is the IRQ and the port IO that goes with that? Who knows that? You know, that's the kind of stuff they're going to ask you, but it is legit. And basically, this is turning on COM 1. Okay. So if I had 2 of these, it would be the first one. Okay. So I'm going to say I'm going to say S0 because that's the one I want here. At Getty TTY. Nope. Okay. Hard to see, but it says SUDO system control start serial dash Getty at TTYS0. What is that doing? I'll go ahead and hit enter. What do you mean? Oh, let's say no. And now if I do status, you can see it's saying it's running, and then there's this error down here. S0 is not a TTY. Means there's something else running on it, which means I gotta go figure it out. I think this one is S1. So I'll have to tinker with this guy a little bit. But this is what you'll need to run on your machines to turn on that 9-pin port. Okay. And then you'll connect to each other. Okay. And how are we going to do this? I'm not exactly sure. But basically, Merry Christmas. Over the years, these have developed legs and they kind of walk away. Really don't need to steal this stuff. It's next to nothing. So basically, you'll need to build out something that looks like this. Okay. Now, what is this? One, this is just USB to a serial port. And then the orange one is something called a null modem. Now, that in essence, remember what null means? It's like 00 hex, means nothing. Okay. In our ports, you count the pins from the top right, move over. Pins 2 and 3, 1 is ground, 2 and 3. They're transmit and receive. What a null modem does is it sits there and takes 2, 3, and 3 to 2. That's all it does. It takes these wires inside and it turns it into a null modem so you can have machines connected, they can talk to each other. Otherwise, talking to transmit, it's like we're both talking at the same time, neither one of us can listen. So when you transmit receive, you can, so to speak, one mouth, one ear, and they can talk. Okay. And then the yellow one is because I ordered the wrong cable, and that's a gender member. Okay. I don't even know if that's a politically correct term or not anymore. I lose track for a while. But I should have enough cables. And so basically what you're going to do is on your computer, you plug this into the back on the tower, and then use the front side on another computer to connect to it. Okay. And if it doesn't reach, you can just plug it into your own, and then we can actually make that kind of sort of work. Okay. So come grab a cable and see if you can have some fun with these. And
All right, I'll get down here. We'll bring that wire closer because that USB port's inside.
make sure you have a null modem
Yeah, yellow, just yellow.
and the gender render. So there's one.
And then
That should
that one
work.
to tux.
That should work.
Yeah, that's right. Gender change. Oh, it doesn't need it. Doesn't it?
And if it doesn't work, we'll come up with a plan B. And
I guess not. Maybe this one.
But the idea is step one,
Okay, yeah, it's different. So
Do that command, okay? Oh, I'm sorry.
It's fine.
Everybody got one?
This is where I think I'll sit. No, there's no shot. It'll reach.
Not long enough?
No, it's fine.
Plug it into your own.
I didn't bring my machine. The one.
No, plug it into your own computer.
Oh, into the.
Yeah, so plug it into the back and then plug it into the front. So we're going to create this weird loop,
Oh,
okay?
ew.
So basically, what you'll do is that I'll try it on this machine too. And I have no idea how this will work. Oh, all right. Extras?
Yeah,
Oh,
we
okay.
thought we needed them, but it didn't end up needing it.
Oh, okay. Oh, you're gonna need it for the cross. Well, come back. Yeah, you'll need to know more. We'll see.
We'll see.
We'll tinker. Let's figure this out. Now I'm using a different. You know what? I should try it on this one
You want to try this one?
with the same one.
Okay.
All right, I'll do the same thing you're doing
So what I did is I ran.
because this computer.
Let's start. Ready to run it. Is system control something you have to install like normally? Like did you install?
Oh, no. The system control is part of the base install. Whether or not you use the server version or Ubuntu, it's system control is, or they call it system D now. And it's part of all Linux distributions, but it's not part of Tiny Core or Alpine.
Okay, that's something you gotta
But it's part of SUSE, Red Hat, CentOS, Debian, Mint, and so on and so forth. Better use one of your cables. I have no idea what I got going here.
It asked me because I ran sudo. It asked me the password for Tux, so just the same. I think it's only asked me once. Yeah, it only asked me once. That's the same.
All right. And it's all because the cables are too short, right?
Yep.
So I need a bunch of USB extensions. That would be easy to do. All right.
Sounds like I'm not gonna need it. I could have just clicked it in and I could like talk to it.
Yeah, okay.
That's cool.
Now the question is, how do I make it work, right? I'm on status on one. Okay. And let's do. So when you plug it in, you do sudo. You have to log in as Tux, and you need to be admin because you have to do sudo dmessage to find out where it got plugged in. So I've got one on USB 0. Okay. Now, it's a little hard to see, but I have the black cable connected to the no modem, connected to the gender mender.
coming around to the USB. Okay,
What was the command that you did
to see if it worked.
Yeah, sudo what?
So, oops, wrong word. So what we'll be doing is this to enable. You type in SYS control. Then you say enable. Have they got into system control in test out? Yeah, you'll be using system control extensively in industry. Okay. And then make sure I get it. That one. Okay. System control, enable. And then I say serial dash Getty. In my case, it's TTYS1. In your case, it's S0. Okay. This machine is using S1 for the mouse pad. So, or S0. So you use S0. And that's 90% of what it's going to be most of the time. TTY S0 dot service. Okay. That turns it on. And then how do we connect? Well, we have to do two things. Well, one thing before we connect.
You just said that's all.
Now let's make sure I got this working right. So in my case, it's S1, so I need to do chmod 777. I have to change permissions. And in my case, it's TTYUSB1, or 0. 0. Okay, so 0 is the one I want. Then yeah, okay, here.
Screen. Yeah.
So,
Well, I mean, yeah, so no. Yeah, yeah, I mean, I guess.
what's the-
Escape TTY. That's escape TTY Oh.
Oops. Flip it around.
Well, I mean, I'm able to open my original terminal too. So I wonder if I close this.
Well, before you close it, see if it's-
Oh, status, that's right.
Serial,
Oh, wait a minute, I should unplug this one. Oh, that's my problem. Oh, duh. Okay.
Oh, what I typed in here, I typed C3. So something like that. I think I typed I just typed Alt F1. That's not. Yeah. I thought it was the two. I was scared. I wonder if it's because I got this mixed up. Alt F1. Yeah, yeah. That's crazy. Yeah, yeah, yeah. I know. That's what I just want to go back to the original view. I don't. Also, let's log in. Oh, it's a. Kill. Oh, yeah. Yeah, more excited.
That's why we just want
Oh, yeah, how to get it from CSCI here. Yeah, who received this? Oh, did.
Interesting.
There's a
No open port.
Not. Dude, I'm fine with waiting. This is not my machine. Yeah. Yeah. Yeah, right. That's why I have it in the media machine. If I break it in the media, I just reinstall it. Oh, really? That's right. A virtual machine that has an outlet. Yeah. I have actually, so I have virtual machine. So I have Windows. And then I have a virtual machine that has yeah, so and then I have a virtual machine inside of there that has Debian 12 with no GUI. Yeah, because I need to really tiny toy, so I have Debian 12 no GUI. Yeah, when I turn it on, it's like in chunks. Let's see if it's doing oh man, it is.
You have another command out there that you can use to kind of tinker with different parameters. It's called GTK term. And it's a relatively new addition. But you can go through and play with the permissions on that. So I have to do the D message to see what got plugged in. So it says it's USB 1 or is it 2? So I'm going to unplug it and plug it in again and see what I get, because I had 2 plugged in and that's where I was getting confused. So there's that one. So it's USB 0. Now I changed the permissions. Now I'm going to try to connect to it, which may or may not work. Well, it's a start. It didn't die. And then did I run? Wait a minute. What am I doing here? I've got. All right. Let's go with a no. All right. What you see here is the end result. And I'm going to have to tinker a little bit to make sure we can get everything to behave. When your machine boots and you see all that stuff roll by, you know, all the things, you normally don't see that when you reboot something over the network. So let's say, for example, this machine needs a change in the BIOS. And I happen to be sitting in New York. How do I change a BIOS setting on a machine that has no console? That's why we are doing this. This is something that you will be doing if you get a sysadmin job. Is, for example, I am looking into hardware for a lights out computer room so I can do anything I need to do on the computers in the back room, no matter where I'm at, no matter what my location is. Now, generally speaking, if you need to make a change on a BIOS setting, you know, before the machine boots, you have to hit a key like F1 or escape or F11 at the machine. Then you get in there and change it, and then you boot the machine. Well, what that is called is out of bounds management. In other words, you need a set of tools that actually work on the outside of your server. Now that can be a serial port, it can be a GUI, it can be a web browser, it can be all sorts of things. But what I'm doing here is that with the Raspberry Pi set up this way, it's set up just like a server would be if it was in New York. So if I reboot this Raspberry Pi and this is configured correctly, I'll be able to watch the entire boot sequence over the serial port and stop it and change it, but there's no BIOS in a Raspberry, so no point in trying that. But that's what I'll do. Let me log in to the Raspberry because I connected it to the network. And by the way, let me give you a piece of hard-won advice. You've got a piece of equipment. I don't care what it is. Let's give it a camera. It's got an Ethernet port on it. Plug it in. How do you find the IP address? Pardon?
IPA.
Nope. Because this is a unit, you have no control. It has no keyboard.
Oh.
It has no monitor. It has no mouse. You plug it in. How do you find the IP address? This is a question for networking. This is a big deal. I had this problem with the Raspberry just today. I know this thing works, and I went to plug it in, and I go, because it didn't boot the graphical monitor. It's because there's something screwed up with my Raspberry with the graphics. Surprise, surprise. I probably blew it up. But I can get it to boot. You can see it. Here it is. But I didn't know how to find what it's for. I could not find the IP address. Well, I could write a script that pings every IP in the subnet. Except on this network, they lock it down. So how do I look for a device when I can't get to it from the network? This is where your understanding of the TCP/IP stack comes in. You have DHCP, which connects IP to MAC. Okay. Now on your local machine, well, then you have DNS, which connects IP to name, IP to MAC. How do you look at your MAC table? ARP. Use the ARP, Address Resolution Protocol, and you type in ARP. You can do it on your computer, and it shows you name or IP address and the MAC address. That's the actual hard-coded MAC address in the unit. But the ARP table doesn't get built unless it's been accessed. So the ping thing didn't work. It locked me down. I go, all right, what's my next step? Well, I used Nmap, and I used Nmap -SN, and then I gave it the IP range that I wanted, which was this. Not 0, and then /24. So it's going to go through 1 to 255. And what it did is it pulled the ARP tables for all the devices. And then I grepped for Raspberry Pi International. And I found my IP address and I SSH into it. Nmap is your friend. It's a very sophisticated tool. Learn how to use it. Okay. All right. Let me go back to where I was started here. And that was just today. I run into these types of problems all the time. Okay. So I'm logged in through the network. And I've got the serial port set up, okay? And let's see. my serial port. I'm on this box, Raspberry Pi, network, power, serial port, which I'll have to figure out how to make it work on these machines. I'll get it figured out. Okay. And now what I'm going to do is reboot, and we're just going to watch and see what happens. Okay. Look what's happening on the serial port. This is because on the Raspberry Pi, there's a configuration that says use the serial port as console. This is what they mean by console on a serial port. We can do that on these machines. We can redirect the output of the console to our little line pin. But the way these machines are configured with Dell, you can't get into the BIOS through the serial port. It's just by the way they've designed these towers, okay? But for the management on the servers, all the servers in the back room, you can. You can actually use the serial port to connect. This is why you will see admins having an old contraption like this that's got a serial port, or they have something like this that converts it into a serial port, okay? I think these are like $6. So it did the whole thing. And I'm now ready to log in. Just as if I had a monitor attached to the Raspberry Pi. So when somebody says, do you need a monitor and a keyboard and a mouse to manipulate a server in New York? The answer is no. You can use the serial port or the out of bounds control. They call it BMC. There's IPMI. There's a bunch of different tools in that space. But the simple one is a serial port. Okay. So having fun with the serial port is, this is when you go to DEF CON, they give you these badges that have all kinds of brains on them, and you have to reverse engineer the hardware. They always have a serial port in there somewhere, and you need ground, transmit, and receive, and you connect to it, and now you're remote controlling your badge as you're walking around DEF CON. It's just fun, okay? And this is what you'll be doing with your irrigation and your greenhouse, which you'll be doing with the hot tub. This is all stuff that's very real, that if you know how to do, you can do this with your car. Down at DEF CON, they had car hacking village, and they had a serial port, TTY, connected to a Ducati motorcycle. So we were sitting in there changing the config to make the Ducati run like a 50cc motor scooter. It would go anywhere. And then you can change the configs to make that thing just scream and blow itself up. It was a lot of fun. And if you've never been to DEF CON, you need to go at least once in your tech career just to see how crazy things are. When I was there last time, they had a full-on F-18 simulator that had all the avionics of an F-18. And they said, here's some tools, hack it. They wanted to see if there was stuff that they missed. They also had voting machines that you could hack. That was way fun. And they also had ATM machines. If you hacked successfully, they let you get $2 bills. And I think the prize was $20 or $50 in $2 bills. So if you hacked the ATM machine effectively, you walked away with real cash. And everybody knows with a $2 bill what you did. You hacked the machine. Now, what's fun at DEF CON is the FBI's there, And so are the bad guys. And there's kind of this gentleman's agreement that nobody gets arrested at DEF CON. Okay. Because there's this, what's over the years, it's been bad guys would try to attack the government. And what's been happening is we will help you if you want to hack Chinese or the Russians and kind of shut down some of this media. We're going to be in a very interesting election cycle because of AI and the state actors who want to get their president of choice in office. It's going to be very interesting to watch. I don't care what side of the fence you're on. It's going to be interesting to see how the propaganda machine is going to run, because one of the new tricks is the subtle psychology of, well, we don't want you to vote for the bad guy, so we'll just get you not to vote at all. So they're tapping into apathy, which is a first. This is interesting. Very interesting. So I will figure out how to make this work so I can show it to you. And then I know I don't have enough extension cables, so I'll order a bunch of those. So how many, we got 3, 5, say 10. So if I got 20 USB extension cables, we could probably do this correctly, because I think there's a problem doing it looping back on itself. The transmit receive isn't right, so I have to figure out what the scoop is. But you know what started all this? I have a nice PC under my desk. It's really slick. It has no out of bounds management. I cannot change anything on that machine unless I'm in front of it. Nuts! Had I known that, I would have bought a different computer. You know, so you learn as you go. Okay. All right. So you can see what happens when it works right. It's behaving. So the Raspberry Pi with the serial port to the USB. So these little wires are the same thing as this 9-pin connector. It's just it doesn't have one. And this, so this is a console that allows me to do all the admin I need, even if there's no network. I can completely control this machine. Now, had I set this up correctly, I wouldn't have had to go through this to find it, but I didn't. I had forgotten about that. So now it's set up right. So now, next time I use it, I can just plug in the serial port, then plug it into the network, and then I can use IPA and find the IP address. Okay. So on that note, I think we're done for the day. Exciting stuff, huh?
It was. Yeah.
All right. Wouldn't it be fun to have a quiz about all this? No, I won't do that. That's not fair. Because this is something I know.
Yeah.
I can almost bet. Has anybody done anything with serial ports in the past at all? Yeah, okay. Yeah, it's usually the case. What the serial port? That's usually what happens in this class.
What you did.
Yeah.
It was a really roundabout thing with COM ports involving a USB. I bought a USB, USB adapter that had a really underpowered terminal, and again, no power, so it goes very slowly. So it's
Yeah.
a weird roundabout process, but it was worth it.
Yeah, because that's what happens with the Raspberry. It's advertised that you should be able to power it over a serial port, but not the Raspberry Pi 3. You need the Raspberry Pi W0. You need the very, very small one. So it almost works. All right. Thank you.
You too, man.
You bet. And return all the cables to that big rat's nest, and we'll see if we get it all working.
Great weekend.
You too. So part of the reason I did this was to show you what you need for yours.
Yeah.
So I did find some documentation on the translation between the 485. Did you get yours to boot?
I haven't quite done it yet, but I did download the thing, so I don't need that anymore. I just gotta put it in and turn it on. Really.
Okay.
Yeah.
Great, because this should behave itself in the big scheme of things. So let's hope.
It'll be very interesting trying to get it to.
Yeah, well, let me know if you need help. I can, and don't be afraid to record video and things. Because I think once we get to the point where your Raspberry Pi is up and running, what we're gonna have, I think our difficulty is gonna be trying to figure out the signals coming off of the 485 interface.
Yeah.
And I did find something. Let's see if it's still here, or did I not? Oh, I closed it down. Nuts. Let's see if I've. There, not there. Oh, the Brave Chromium Restore. Ah, here we go. Okay, this is the actual cable that this is the cable that I was showing you. That's what I've got for the Raspberry right here.
Okay.
And then this is the serial. And then is it this one? That's showing you the transceivers of 485. And see, this is using an actual breakout board that gives you more signals. Let's see here. No. Can't remember. Somewhere I saw something. Oh, here we go. I think it was this one. There we go. Part of my interest is to be able to connect either RS-232 or 485. Okay. And it shows you this 485. You're a 485, right? That's
Yeah.
what you're looking for?
Yeah.
And this is showing you the signals of all this. Let me just print that. So the Raspberry Pi, and you bought the little adapter.
Yes.
Yeah, let's do this. I'm going to print that out too. He's walking you through the process, but I believe this is a little dated. He doesn't have the date on here.
That's a Pi 3, but it's probably.
Yeah, well, the pinouts on the GPIO are the same. The difference between the 3 and the 4 is the 4 has USB 3 rather than the old USB 2 stuff. So it's got It's got faster USB. Now, this is probably more information than you need to know what to do with, but it's a start. So half of it is going to be the, this is pretty technical stuff. This is showing you the actual signal level of what the 485 is. And then this is getting this to work. And then how do you do what I did here? Now, you are doing something a little different. You are doing the equivalent of this in the Raspberry going to the 485 connector.
Yeah, which is in the heater.
Right.
Yeah.
Right. And I know I've gotten this to work with the Raspberry. I actually got it working on my machine in the office. It's the only way I could get out of bounds. I don't think that'll work. Something like that. But yeah, that's kind of where we are. It's that's off. Okay, so it's connected. Now, I doubt this would work, but it might. All right. See, it's what's it called? It's T2I0, right?
Yeah, I believe.
Yep, there it is, 0. And then screen. No, TTY. Oops, I don't have it installed. I'll mess with it later.
Well, thank you for
You bet.
this.
We'll get it all figured out. You know,
Yeah.
it's we'll be plodding along.
Yeah, yeah. So once it's connected, how is it gonna? So I'm gonna have to like actually program it before putting it in there, right? Or because
Well, I think what we're gonna, I don't know exactly what the process will be, but you have the little connector that converts 485 to RS-232, right?
well, it's USB.
Yeah, USB to 485. Yeah,
Yeah, yeah.
you've got that. What I'm not sure is which wires going to need to go to which connectors.
Yeah, yeah.
And that's, I don't know what the right answer for that one is.